Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Today I want explain my presentation about utilization of metakaolin as an alternative artificial material for liquid aggregate. Here, some presentation about abstract, introduction, material, result and discussion, and conclusion. And next, we talk first about abstract. The study aims to find the optimum composition of mixture for the manufacture of artificial liquid aggregate. The method of making a mixture of the material is trial and error. Method with the target weight of 1,100 kilogram per meter cubic. The ratio of Na2S3 and NaOH in the preparation of aggregate was 2:1, and with concentration of 10 molar, the mixing process used by variation of comparison. With A, 100% metakaolin, B, 75% metakaolin and 25 PAS, and C, 50% metakaolin and 50% PAS, and D, 25 metakaolin and 75 PAS, and A with 100 PAS. The test was conducted by using two different test specimens. Is cylindrical test object with diameter of 2 cm and height 4 cm, when for a cylindrical test object was done by furnace with temperature 300 degrees for 6 hours stage, and for other tests specimens were rounded with of diameter 20 cm. 2 cm, sorry. And next, introduction. From the Pusdatin SDM, Indonesia has abundant natural resource, one of which is kaolin mining material. Based on information from Pusdatin SDM, the potential and large kaolin reserves in Indonesia were found in West Kalimantan, South Kalimantan, Bangka, and Belitung Island. And Kijong mining product is 2003 amounts to 700,000 and 2 and 302 and 5.49 tons export abroad. And Zinjix fell in 2010. Liquid concrete can be produced using liquid aggregates that are generally divided into two, namely natural artificial, and liquid aggregates. And this research was conducted to obtain the optimum composite of metakaolin and fly ash mixture. And then there are 5 composition when I taught in abstract. And their compressive strength value from weight and I see compressive strength value, volume, weight, and porosity of artificial liquid aggregate. And then the artificial liquid aggregate of metakaolin is expected to be benchmarked on other artificial liquid aggregate, so that the large kaolin mining commodities in Indonesia can be processed into something useful. And next, some material. Before I continue to my presentation, I will tell you about some materials. The first material is metakaolin. Metakaolin is some process from kaolin. What I tell before, metakaolin is compound different from the combustion process or calcination of kaolin minerals with temperature of 700 degrees Celsius. The density of metakaolin from the analysis was 2.36 gram per centimeter cubic. And next, the second material is fly ash. Fly ash is coal burning residue. Fly ash material used to come from petrokimia industry. In this research, I was use fly ash from petrokimia industry, and this material is commonly used in making biopolymer concrete. The fly ash weight is 2.47 gram and per centimeter cubic. However, when compared with the metakaolin weight, and then is some material, and the last material is alkali activator. The activator is intended in this region are sodium hydroxide and alpha and sodium silicate, and then the capillary side is Na2SO3 contain 96% gel space sodium silicate, while alpha is powdered with 98 sodium hydroxide. In this study, the ratio of Na2SO3 R and alpha is to combine 1 and with 10 molar concentration. In this alkali factor is the same useful like a water, water in cement, but this some biopolymer progress, so we cannot use water, but we can use alkali activator to combine our biopolymer. Okay, next. And now we speak about result and discussion. In my purpose from the journal, we must talk about some kimia chemistry about fly ash and metakaolin, and then there some results about SLF analysis metakaolin and fly ash, and then the table and the discussion about besides the more dominant chemical properties in SeO2, Al and Fa, the calcium, Al and magnesium. This some SeO2, Al, ammonium, and still this some chemistry was there in cement, but in this fly ash and metakaolin there too. This some new reason why we use fly ash to make some concrete before we don't use a cement, because in this chemistry there some chemistry in the cement. And next we talk about the porosity, and then the porosity is like there in table, and the talk about porosity is high close porosity flows allows to be able to support the good value of compressive strength test. There are two porosity tests. There are close porosity and upper porosity. And this from this quantization, when compared of the variation, the MK2 variation has high close porosity value. MK2 was a variety on the optimum composition in the test. And then the MK2 with 75% fly ash and 25 choline is there. The good compare about this result. And then about the strength, and we talked before in this, and we talked before this ratio conduct uptime we found some optimum composition, and then we know the result of the optimal composition is there in NK2, that is 40 MPa. Then this is higher than another. This NK2 is the porosity is some 75% metakaolin, fly ash, and 25% metakaolin. Then is there is graphic. Some graph is then is MK2 is higher than another, and then we can take a conclusion about the good composition, about the optimal composition there in the MK2, where the composition is 75 fly ash and 25% metakaolin, and the porosity and density this time the higher porosity, the higher composition in MK2 is the, in the conclusion we can use some some composition to make some aggregate with liquid aggregate. In this picture we can see how the liquid aggregate mixture. And then in this reference, okay, and thank you before. Assalamualaikum warahmatullahi wabarakatuh.